Now let's take another look at the transistor. Now the problem is with the insulator. Now the insulator's job is to keep electrons contained within the transistor during normal switching operation. However, in the case of 45 nanometer process technology, that insulator is only 5 to 6 atoms wide. Not a whole lot of material to work with. The risk is that the insulator can break down, electrons can freely escape, and we will have uncontrollable levels of leakage current. Now the technology manufacturing group, they decided the only way to alleviate this problem was to choose a different material for an insulator. To do this, they looked at a deep, dark corner of the periodic table and found a relatively unknown and certainly underappreciated material called hafnium. Now hafnium was a great fit because electrically it can be very thick while being very thin physically. Now this represented a significant departure from the silicon oxide transistors that we've been using since the 1960s. However, 4 years ago, the Technology and Manufacturing Group decided to research hafnium as a viable alternative for 45 nanometer process technology. What would happen if they failed? It's certainly not a pretty picture. What happens is that Moore's law would stagnate, and of course, as such, the innovation that we've enjoyed in computing over the last 30 years would also stagnate. It's a grim reality. Luckily for us though, the Technology and Manufacturing Group was able to produce the first 45 nanometer processors in early 2007. Now in November of 2007, those processors are available for us to consume and enjoy. On the server space, we have the Xeon 5400 series processors, and we also have released the desktop Extreme Edition QX9650 quad-core processor. Both of those represent best-in-breed technology for their respective market segments.